Today's video is going to be doing a past paper question on coordinate geometry. This question comes from an Edexcel past paper, but is applicable to all A-level maths exam boards. So the question we have is the one that's on the screen. So let's just dive right into it. Let's take a look at the actual question. So we have a circle and it gives us the centre of the circle coordinates, and we also have a tangent to the circle, and it wants us to find the equation of the line PA. Alright, so I've just removed the parts B and C of the question so we can just focus on part A for now. So it wants us to show that an equation of line PA is 2y plus x equals 17. Alright, so what information do we already have? We already have the equation of this line here, which is the tangent to the circle. We're given that that's y equals 2x plus 1. Alright, so line PA is a straight line, and the equation of a straight line takes the form y equals mx plus c, where m's the gradient and c's the y-intercept. So let's start off by trying to find the gradient. Now, can you see that PA is the radius of the circle and it touches the tangent? Now, we know that those two lines must be perpendicular, as where the radius meets the tangent, those two lines are perpendicular. So, what else do we know about the gradient of two perpendicular lines? We know that the gradient of two perpendicular lines multiply to make minus 1. So, the gradient of line L is 2, which we get from this equation up here. So we know that 2m, they multiply together to make minus 1. So if we rearrange this equation, we get m to be minus a half. So now we have the gradient of our line PA. Now all we need to do is find the y-intercept, which is c, and we're just going to do that by substituting in some values. So we can see that up here we're told that the circle C has centre A with coordinates 7, 5. So we know that the coordinates here must be 7, 5. So the coordinates 7, 5 go through the line PA, so we can substitute that in to our equation. So far we know that the line PA has the equation y equals minus a half x plus c. Now substituting in 7, 5, we get 5 equals minus a half times 7 plus c. Now let's just expand this out. So we have 5 is equal to minus 7 over 2 plus c. So then we get c is equal to 5 plus 7 over 2, which gives us 17 over 2. Cool, so now if we put that in to our equation, we have y equals minus a half x plus 17 over 2. And with a bit of rearranging, we can get that into this form here. So I'll just quickly do that for you. So if we multiply everything by 2, we get that 2y equals minus x plus 17, and then we're just going to plus the x. So we have 2y plus x equals 17, as required. Cool, so that's part A done. Let's move on to part B. Alright, so moving on to part B, we have to find an equation for C. So C is a circle, so let's just write down the general form of an equation of a circle. So we have the equation of a circle is y minus y1 squared plus x minus x1 squared equals r squared, where x1, y1 are the centre of the circle. So we can actually fill those in straight away. So we can write y minus 5 squared plus x minus 7 squared equals r squared. So now all that's left for us to do is to find r, the radius of the circle. So we're going to use this point here, which is point A, 7, 5, and we're going to work out what this point here is, point P, and then we're going to use a formula that allows us to calculate the distance between 2 points. So how are we going to work out point P? Well, we know from part A that the equation of PA is 2y plus x equals 17, and we also know the equation of line L. So we're just going to find the coordinates of where they intercept, and that will give us point P. So we have 2y plus x equals 17, and then we have y equals 2x plus 1. So I'm just going to substitute the second one into the first equation. So we're going to have 2x plus 1 plus x equals 17. Alright, so expanding, we get 4x plus 2 plus x equals 17, and then simplifying, we get 5x plus 2 equals 17, and then rearranging, we get 5x is equal to 15, so then we can now solve to find that x is equal to 3. Cool. Now we can substitute x back in to find the value of y. So we know that y is equal to 2x plus 1. So y is equal to 2 times 3 plus 1, which is equal to 6 plus 1, so that's 7. So now we have our coordinate of P. We know that's 3, 7. Great, okay, so now we can use the equation to find the distance between 2 points to work out the radius. So for those who aren't familiar, the equation to find the distance between 2 points is y1 minus y2 squared plus x1 minus x2 squared, and then we just square root that. So substituting the values in that we have, we'll take this to be coordinate 1, and we'll take this coordinate up here to be coordinate 2. So the first y value here is 7, and we take that away from the second y value, which is 5. And then same for x. 3 minus 7 squared. Get the 3 from here and the 7 from here, and then square root it. So we get 2 squared plus 3 minus 7 is minus 4 squared, square root. So that's 4 plus 16, which is the square root of 20. So we found out that our radius is the square root of 20. So plugging that into here, we write that r squared is obviously the radius squared, so it'll be 20. So the final equation of the circle will be y minus 5 squared plus x minus 7 squared equals 20. Alright, so moving on to part C. It says the line with the equation y equals 2x plus k, where k is not equal to 1, is also a tangent to C. Find the value of the constant k. So the first thing here to notice is that the line they want us to find has a gradient 2, which is the same as the gradient for the line that they've already drawn onto the graph. So lines with the same gradient are parallel. And we know that this line, let's call this line L2, we know L2 is also a tangent to C. So it must go in one place, which is here. That's the only place on the circle where it can go, where it's parallel to line L and it's also a tangent to the circle. So how are we actually going to find L2? Well, we know L2 is y equals 2x plus k, but we have to find what k is. And the way we're going to do that is by finding a point on the line and then substituting it in to find the value of k. And the point we're going to find is this point here, where the tangent touches the circle. We already know from part A that the line PA is 2y plus x is equal to 17. So this line is going to extend all the way down because PA is obviously only part of the line. So what we're actually going to do here is find the point of intersection for this line here, 2y plus x equals 17, and the circle. And that will give us this point of intersection and this point of intersection. We already know what this one is, which is 3, 7, so we just need to work out what the other one is to find this point. So now we just need to do some basic substitution. So we're just going to rearrange this and put x is equal to 17 minus 2y. Now substituting that into here, we get y minus 5 squared plus 17 minus 2y minus 7 squared is equal to 20. Y minus 5 squared plus 10 minus 2y squared equals 20. So expanding, we get y squared minus 10y plus 25 plus 100 minus 40y plus 4y squared equals 20. With a bit of rearranging, we end up with 5y squared minus 50y plus 105 equals 0. So I'm just going to divide everything through by 5, so we're going to get y squared minus 10y plus 21 equals 0. And then we're going to factorise, so we're going to get y minus 7, y minus 3 is equal to 0. So solving this, we end up getting that y is equal to 3 or y is equal to 7. And those two coordinates that we've just found are the y coordinates for where this blue line here intersects the circle, which you can see here, y is equal to 7 is this point here, P. Where y is equal to 3 will be this point here. Let's just call this Q. So now we have the y coordinate. We can easily find the x coordinate by substituting it back into either the equation of the circle or the equation of the line PA. So we're just going to substitute it in here. So we're going to get x is equal to 17 minus 2 times 3, which is equal to 11. So the coordinate Q is 11, 3. Alright, now we know that the point Q is the point 11, 3. We can now substitute this into this equation here. So we have y is equal to 2x plus k, and we have 3 is equal to 2 times 11 plus k, and then rearranging this we find that k is equal to minus 19. That's the first way to solve part C. There's a second way which is slightly quicker. Now this second way uses vectors. So we see here that the line L is directly opposite the line L2. So what we're going to do is we're going to work out the vector OP. So we know that OP is just going to be the coordinate 3, 7. Now we want the vector PA. So we want to go from P to A. The way we're going to do that is we're going to go back down this vector here. Instead of the OP vector, we want minus OP. And then we're going to plus OA. Because once we've gone down here, we want to go back up here to A, which is the vector OA. So this is going to be minus 3, 7 plus OA, and that's just going to be the coordinate of A, which is just the centre of the circle, which is 7, 5. So adding those together, we get 4 minus 2. Okay, so to get to this point here, Q, what we can do is we start from the coordinate P and we go down PA, which is this vector here. But then to get here, we just apply the same vector again. Essentially what I'm saying is we need to do OP plus 2PA. And that will take us to Q. So we get 3, 7 plus 2, 4 minus 2. And that will give us 11, 3, which is the point Q. And then we can finish off the question by substituting this point in here and finding that K is minus 19 again.